Welcome to the RPTM podcast, the show that breaks down the myths of monolithic history and tells our story through multiple lenses. I'm your host, Professor Ryan Lancaster. Today's episode is partially underwritten by you, the listener. Find out ways to support the podcast on my website, ryanglancaster.com. Episode 1. Precambrian, Paleozoic, Mesozoic, and Cenozoic Eras. Before we get started, we need to mention rule number 1 for understanding history. Historians are detectives. Much like Batman or Sherlock Holmes, historians look at the crime scene, in this case the historical event, look for clues, in this case books or archaeological sites, interview witnesses, in this case secondary or primary sources, and interpret the findings to determine what happened. Much like an actual crime scene, the investigator must rely on what they have in front of them. Missing pieces always happen, but it's the goal of the historian to fill in the blanks with what his or her gut tells them. Or they go to their utility belt of previous knowledge to help determine the most likely outcomes. This becomes rather difficult the further we get from the time frame of the crime, or what is referred to as a cold case. Scents get thrown off, memory gets muddled, the picture becomes murkier as time slips from our grasp. Why do I mention this? Remember that as we dive into the world of prehistory, we don't have all the answers, and never will. But don't worry, I'm Batman. To start looking at the history of the United States, we have to go back. I mean, really go back. That's it, keep going. The Precambrian Era. The name means, get this, before the Cambrian period. This old, but still common term was initially used to refer to the whole period of the Earth's history before forming the oldest rocks with identifiable fossils in them. The Earth is estimated to be approximately 4.6 billion years old, an age obtained by dating meteorites. Rocks dating to around 4 billion years old are found on almost every continent, but the oldest stones known on Earth are 4.3 billion years old. These rocks can be found along the eastern shore of Hudson Bay in northern Quebec. They are part of the Canadian Shield, the ancient core of the North American continental landmass, which has experienced very little tectonic activity for millions of years. Shields are the stable cores of all continents and are covered by layers of young sediments. They formed and grew during pulses of magmatic activity, as bodies of molten rock deep in the Earth's crust contributed to creating a new crust. The oldest rocks identified so far in northwest central United States are 3.6 to 3.8 billion years old in Wyoming's Wind River Mountains. What we tend to overlook is the sheer amount of time we are looking at here. The Precambrian covers almost 90% of the entire history of the Earth. It comprises all geologic time before 600 million years ago. The Precambrian was initially defined as the area that predated the emergence of life in the Cambrian period. It is now known that life on Earth began by the early Archean, and that fossilized organisms began more abundant throughout Precambrian time. The oldest known eukaryotes lived around 1.4 billion years ago, during the Precambrian near Beck Springs, California. These photosynthetic organisms produce oxygen as a byproduct of their physiology. The Beck Springs eukaryotes and other Precambrian photosynthesizers release the oxygen that now makes the planet's atmosphere breathable. Precambrian blue-green algae remained from this age were preserved between Copper Harbor and Eagle Harbor on the shoreline of Lake Superior in the Upper Peninsula of Michigan. The appearance of the first eukaryotic cells in the fossil record were relatively followed by the evidence of complicated multicellular life. Rocks in Nevada dating back to 1 billion years ago preserve trace fossils left behind by worms as they burrowed below the sediment. But as you gathered, all good eras come to an end. The remainder of the Precambrian period saw the formation of a supercontinent, which geologists call Rodinia, about 1.1 billion years ago, and its eventual breakup about 750 million years ago. Preserved remnants of the continental collisions that formed the supercontinent are found widely across modern North America, and very few of these elements are recognizable in the United States. Rodinia's breakup was associated with the formation of rifts throughout North America, with igneous activity occurring in rift zones and continuing slowly and irregularly until about 600 million years ago. North America's rifted edges formed passive margins where sediments were deposited on continental shelves into the early Paleozoic era. The Paleozoic. As we continue, I just have to say that I will not do this time frame justice. It is an amount of time that is inconceivable to the human brain, and quite frankly, there are smarter and more attractive people that could describe the flora and fauna that is birthed during this era. I suggest you contact them for more details. Keep in mind, as I butcher the names of the Lovecraftian sea beasts, that I am merely your humble narrator. At the start of the Paleozoic, during the Cambrian, the area that it now comprises California, Oregon, Washington, and western Nevada did not exist as part of the North American continent. The continent's western coastline was located at approximately the Utah, Nevada, and Arizona, California state lines, where a broad continental shelf extended westward from the coast. The shore moved eastward over time as the sea level rose, covering much of the western U.S. under a shallow sea, and sheets of sand and carbonate sediment were deposited on the shelf. By the end of the era, global temperatures and sea levels fell abruptly, probably due to glaciation caused by the vast southern supercontinent Gondwana movement over the South Pole. As a result of these environmental changes, major mass extinction in marine life took place at this time. Sea levels continued to rise and fall throughout the first half of the Paleozoic, leaving marine sediments during transgressions and allowing the exposed carbonate rocks to weather during regressions. All known life during the Cambrian was aquatic, so areas of the United States above sea level would have been sterile wastelands. Trilobites are the most common kind of animal in the Cambrian fossil record. Brachiopods, gastropods, and sponges were also crucial for Cambrian animals. Sea levels around the North America dropped at the end of the Cambrian. Ecosystems in shallow water were probably devastated. The Cambrian ended with mass extinction. Globally, brachiopods and gastropods lost much of their biodiversity. Sponges lost about half of their families, and almost 3/4 of present-day trilobites' families vanished. 443 million years ago, warm, shallow seas covered most of North America. Illinois, Indiana, and Michigan were home to vast coral reefs. The reefs of Indiana were among the most diverse of the period on the entire continent. Southeastern United States was still part of Gondwanaland during the time. Only the Michigan and New York areas, then near the equator, were still inundated. However, these landlocked seas were not being replenished by fresh water, so gradually evaporated, leaving concentrated salt deposits in those regions. 419 million years ago, North America once again experienced home to seas that teemed with life. In fact, marine life may have been more abundant and diverse than at any other point in the Paleozoic. Glass sponges became abundant in western New York during this time. Especially noteworthy are the marine fossils of Cuyahoga County, Ohio, which was home to more than 120 kinds of marine life. The local fishes alone left behind more than 50,000 fossils. The plants responsible for leaving behind fossil record seeds may have been seed ferns, plants whose fronds resembled ferns, but who reproduced through seeds instead of spores. Then, 323 million years ago, the northward drift of Gondwanaland finally joined with the southeastern United States and North America as Pangaea began to form. Mountain building raised the ancestral Rockies in Colorado, Utah, and Wyoming. Seawaters left the interior of the country. Densely vegetated swamps were widespread. The largest insects in geologic history lived during this time. Giant salamander-like amphibians left behind footprints near Lawrence, Kansas, that would later fossilize. Fossil footprints from this time were also preserved in eastern states like Alabama, Georgia, West Virginia, Ohio, and Pennsylvania, where fossil footprints are known to be found. The world's continents were joined at Pangaea roughly 298 million years ago. Volcanic activity occurred on the west coast. Seas were present in the southwest and west coast. The waters of Texas were home to massive reefs made of spined brachiopods jumbled together. Seas that had previously covered Kansas, New Mexico, and Texas began drying up and left behind salt deposits. The inner portion of the western United States had a hot, dry climate. Dunes were prevalent throughout the country. The insects of the time were common and diverse. Large amphibians were not rare in the southwestern United States, but were unable to stray too far from water bodies. Reptiles were becoming common during this time. Texas was home to the Dimetrodon. Later in the Permian, therapasids became the dominant large-bodied land-dwelling vertebrates. These were the forerunners of mammals. The Permian ended with the most destructive mass extinction of all of Earth's history. Globally, up to 96% of all species may have disappeared. Sea levels fell again in the late Paleozoic as continental collisions progressed to form the supercontinent Pangaea. Over time, the coastline moved farther seaward, running through western Montana, eastern Idaho, central Utah, and western Arizona. The climate at low altitudes of the supercontinent was hot and dry, and iron-rich limestones, sandstones, and mudstones were oxidized. This progression produced rocks with a distinctive and characteristically red color, appropriately called red beds. Permian red beds were very typical of the Southwest, particularly in the Colorado Plateau region, where they are the most widespread geologic feature exposed. Many of these red beds represent ancient dunes. Meanwhile, the marine Permian Basin, southern New Mexico, and west Texas was ringed by reefs. The Guadalupe Mountains of southern New Mexico and western Texas contain the most extensive and best preserved Paleozoic reef in the world. Regression of the sea near the end of the Permian period spelled the end of the Southwest magnificent reefs. Mesozoic Era. The eastern United States was part of Pangaea's interior for most of the Triassic period of the Mesozoic Era, roughly 250 million years ago. At the time, the area lay close to the equator and was connected to Western Europe and Africa. The union of all Earth's continents into a single landmass changed how the atmosphere and ocean circulated. This left what is now the eastern U.S. with a hot climate and pronounced seasons. The western United States was covered mainly in seawater during the late Triassic. Mountain building and volcanic activity were ongoing in the same region. On land, North America's vegetation included plants like conifers and ferns. The Triassic vegetation of the East Coast indicated muddy conditions in the local rift valleys. Arizona was home to a vast forest that would later leave behind the area's famous petrified wood. Reptiles first began claiming the ecological dominance of marine, terrestrial, and aerial habitats during the Triassic that would earn the Mesozoic the name the Age of Reptiles. Did you make it this far? Good. Here's the payoff. Dinosaurs. 5-year-old Professor Lancaster spent an ungodly amount of time thumbing through books about thunder lizards. I mean, it was unhealthy. This is important to remember as dinosaurs were widespread within the regions now composing the modern United States. This is also an excellent time to point out again that we are detectives. We go with the facts that we have inferred, the rest later. Dinosaurs are a fantastic example of how that works, or in some cases cease to function. In my youth, Going off the mid-80s science of the time, dinosaurs were cold-blooded tail draggers. The Tyrannosaurus rex was an apex predator, one that was king of all monsters. As I currently record this, according to new research, it suggests that dinosaurs were warm-blooded and had feathers. The most significant blow to my childhood is the T-Rex was a scavenger, not a predator. The deadliest killing machine of all time is a mere oversized chicken. Man, what a bummer. Dinosaurs left behind abundant fossils in the Four Corners region, or the southwestern corner of Colorado, the southeastern corner of Utah, northeastern corner of Arizona, and the northwestern corner of New Mexico, and are now known as one of the best sources of late Triassic dinosaur fossils in the United States. The oldest dinosaur remains in the eastern U.S. and is about 225 million years old. So, dinosaurs had reached the east coast of the United States not long after they evolved in the first place. Fossil footprints are the most common kind of early dinosaur fossil in the United States. As the Triassic ended, Pangaea was breaking up into separate continents again. Rift valleys formed along the east coast as the North American, European, and African plates diverged. This process created rifts down the east coast to Florida. One of these rift valleys was inundated with ocean water and became the young Atlantic Ocean. Volcanism related to the tectonic process fracturing Pangaea also left deposits in the eastern U.S. At the end of the Triassic, another mass extinction occurred. Globally, this extinction event wiped out roughly 1/4 of families. On land, most families of amphibians and reptiles became extinct. The eastern coast of the U.S. became warmer and wetter during the early Jurassic. The newly formed Atlantic Ocean brought with it contact with more humid air. The Pacific Plate forced its way under the North American Plate, triggering geologic upheaval on the west coast. Ichthyosaurs remained the dominant marine reptiles of the early Jurassic. Still, as the Jurassic progressed, that title was gradually transferred to the plesiosaurs. Local mammals diversified significantly during the Jurassic, some 145 million years ago. Local dinosaurs included sauropods, Apatosaurus or the Diplodocus, and the theropod Allosaurus. Surprise! Unlike many periods of geologic history, the Jurassic did not end in a mass extinction. There were, however, lesser extinction events going on at the time, with notable losses occurring among ammonoids and dinosaurs. During the late Cretaceous, some 70 million years ago, the Gulf of Mexico had expanded through North America until reaching Alaska. Up to half the continent's new surface area may have been submerged by the sea. This is called Western Interior Seaway. It covered most states like Texas, New Mexico, Oklahoma, Colorado, Kansas, the Dakotas, and Wyoming. The seafloor was smooth and probably never submerged by more than 600 feet of water. A great diversity of invertebrates flourished both on the bottom and in the water column. Near the end of the Cretaceous, the Western Interior Seaway began to withdraw. This regression would end up resulting in both halves of North America reuniting. As the seaway withdrew, the coastal plain expanded southward into northern parts of the western interior. Powerful geologic forces began to fold and distort the rocks of Idaho, Utah, and Wyoming, starting the process that would form the Rocky Mountains. Rivers flowing across the eastern part of what is now Montana deposited sediments known as the Hell Creek Formation. At the time, Montana was home to some of the most famous dinosaurs, including the Triceratops and Tyrannosaurus. You know, the giant chicken. The Cretaceous ended with another mass extinction. This one was second most devastating in geologic history. Roughly half of all animal families became extinct. The most popular explanation for the mass extinction at the end of the Cretaceous is it resulted from a meteorite impact. That impact would explain the high levels of substantial element iridium in sediments from that time. For those who don't know, iridium is a very rare mineral in Earth's crust, but is way more common in meteors. Cenozoic Era. While dinosaurs are fun, I think a very overlooked part of all of this is the fuzzy guys. The fauna of ancient America is both fascinating and terrifying in one breath. Imagine all the animals that roam our world today. Now, imagine them 3 times larger and with extra horns and tusks. That pretty much sums up the Cenozoic. The global climate of the early portion of the Cenozoic Era, some 66 million years ago, was much warmer than it is today. The overall environment of the Earth was much more consistent regardless of the proximity to the equator. The Cenozoic Era is also known as the Age of Mammals because of the extinction of many giant mammals, allowing smaller species to thrive and diversify because their predators no longer existed. With the extended time covered by the period, it is beneficial to discuss the animal population by the milestone of the era rather than generalities. The beginning of the Paleogene period was time for the mammals that had survived from the Cretaceous period. Later in this period, rodents and small horses are common, and rhinoceroses and elephants appear. As the period ends, dogs, cats, and pigs become commonplace. Other than a few birds classified as dinosaurs, most notably the Titanus, the dinosaurs were gone, but large, flightless birds thrived. The Neogene period, 23 million years ago, gives rise to early primates, including early humans. Bovids including cattle, sheep, goats, antelope, and gazelles flourished during this period. Cave lions, saber-toothed cats, cave bears, giant deer, woolly rhinoceroses, and woolly mammoths were dominant species during the Quaternary period. Without the dinosaurs, plant life had an opportunity to flourish during the Cenozoic Era. Nearly every plant living today had its roots during this time. During the early part of the era, forests overran most of North America. However, as the climate cooled, forests died off, creating open land. Due to the widening oceans, sharks, whales, and other marine life proliferated. The Great Lakes that formed in the western United States during this time were the perfect home for bass, trout, and other freshwater species. As the forest thinned, grasses began to spread out over the plains of North America, and savannas covered the land in the middle of the continent. Among the ordinary plant life were pines, mosses, oaks, and grasses. Flowering plants and edible crops dominate the landscape in the later part of this era, as humans cultivate it. You've been listening to the RPTM podcast. If you like what you hear, please rate us on whatever platform you're listening on. Join us again next week when we talk about the seen and unseen of U.S. history. Make sure you subscribe to the podcast so you never miss an episode. Also, for more information, check out the show notes on my website. The show was produced by me. Our editor is me. Written and researched by me. Music is Down South by Bliv Beats. I'm Ryan Lancaster, and this was the RPTM podcast.